All right. We still have a few extra midterms laying around. I'm not sure why people haven't picked them up yet, but if you haven't, there's a few up here. After class, maybe pick them up. Some people asked about context-sensitive languages. We skipped over them. They're not going to be on the final. I mean, not that they're a big deal. Context-sensitive languages is like context-free languages, except on the left-hand side of every production, you can have not just a single variable, but multiple variables, or even a mix of variables and characters. That's it. That's context-sensitive languages. It turns out they're as powerful as Turing machines, and you can simulate a Turing machine with a context-sensitive language by simply having a single variable tracking the read-write head, and the entire partial sentential form as you derive is the contents of the tape. There, now you know. But having said that, it's not going to be on the exam, so don't worry about context-sensitive languages. So I sent an email. Yeah, question? Oh, is the mic not on? Is this better now? Okay, good. So I sent an email a couple of days ago. In the second half of this lecture will be like an Ask Me Anything questions kind of session, so hope you have some good ones. Tesla Demo Day, we said will be next Saturday, 1 p.m. It occurred to me if some people want to have it, if enough people want to have it on a Sunday as opposed to Saturday, that's okay too. How many want to have the Tesla Demo Day on next Sunday rather than next Saturday? So a day later, would it be better? How many would rather have it Saturday? Okay, Sunday? Okay, so it looks like Sunday was probably better. Time, 3 p.m. Sunday, next Sunday of, so it's not this Sunday, it's Sunday subsequent, the 12th, Sunday the 12th. That's the Sunday we're talking about. So 3 p.m. Sunday the 12th. Oh, is it the 14th? Oh, that's right, because Friday is the 12th, the last day of the midterm, of the final exam turn. All right, so Sunday the 14th, 3 p.m. How many are good with that? Okay, how many have a conflict with that, or rather have it some other time? Maybe is a little later in the day good? Because it could last a while, so 3 to 4 or to 4:30 or to 5. Could you make it a little later? Or? All right. Anyway, but it looks like most people want it on Sunday, so let's make it Sunday the 14th, 3 p.m. I'll send you an email reminder. Should be fun. Any other questions? So the final exam, as I said in the email, will be released in a couple of days. You'll have a long period of time to do it, up until the Friday the 12th, 5 p.m. Similar format to the midterm. It'll be a take-home. Actually, we never voted if you wanted a take-home or an in-class. How many want the final to be in class? All right, take-home. Wow, I've never seen such a majority in my life. Okay, good. So democracy works. We'll have it take-home. I didn't want to be presumptuous. You always have the choice. So it's mostly questions that you've seen before. I may use slight, tiny variations on questions. So it's not completely identical, but 95% identical to a question, just so that I want to save you from copying an answer onto an exam that you don't even understand. My gift to you. So if you don't understand what you're copying, it'll be pretty obvious if the answer is slightly tweaked. I reserve the right to do that. Some questions will come verbatim, a few will be slight tweaks, just to see and make sure that you understand what you're writing down. Some people tend to abuse the system, abuse our goodwill and generosity, and just copy a lot of answers from other people, don't even think about it, just copy it down on the exam and walk away as if they won the lottery. That's not real learning, it's just copying. So, if you copy stuff down, let's make sure you understand what you're even copying. Never mind where you got it from, okay? During the exam, of course, there's no Google searching. This is not a course about Google searching, even though, again, some people have abused that. But that's all right. It's a growth, it's a learning experience for all of us, myself included. Any other thoughts, questions about anything, logistics? All right. So last time we talked about the Turing test, robotics, AI, artificial intelligence. We've been using robots for a long, long time, especially in space. In fact, in space, it's only really the only option we have in many cases. You want to send some presence to Mars, it can't be human, not yet, unless you're Matt Damon in The Martian, and even he had some issues being up there. So we've been sending robots to Mars since the 1970s. There's Carl Sagan with the space probe to Mars back in the 70s. And today we have smaller, even more sophisticated probes all over Mars. And even the other planets, it's all robots exploring the solar system. And they have to have AI because if you're going to Mars, you're half a light hour away. So if the robot gets into trouble or is about to fall into a crevasse or having some issues, there's no time to call home and wait for an answer. It'll be an hour long. So it has to have sentience and artificial intelligence on board to figure out what to do on its own. And if you're near Jupiter, it's several hours, and if you're near Pluto, it's one light day. It takes an entire day for light to get from Pluto to Earth, roughly. And we have probes that have passed by Pluto and its moon Charon and other even farther down the solar system. So in a two-way round trip for light, there's no time to wait on us to make decisions. It has to be smart enough to do the right things on its own. Anyway, robots have been in factories for many decades. Car factories are almost completely automated today. Robots can work assembly lines single-handedly. Robots are even in your homes right now. There's the Roomba vacuum cleaner and a whole bunch of other clones of the Roomba. That's been going on for 15 or more years. You've probably seen them. Many of you own one. I do. I own two, actually. The trick is to turn them on so that they'll actually do the work. Sometimes even that's kind of onerous, right? And robots can play soccer. There's robot dogs, the Aibo. It's a product. It's expensive, but it's a mechanical pet. It can fetch things for you. And they've been evolving quite a bit in recent years. So this is the evolution of the Asimo. They used to be big and clunky, and now it's a lot smoother and cooler. It's by Honda. That's the entire line of prototypes. It's gotten smaller, more sophisticated, with more sensors. It even conducts an orchestra. There's Yo-Yo Ma trying to show his appreciation with a kiss, I guess. And conducting an orchestra actually is harder than it sounds. You have to have a lot of agility and a lot of haptic feedback and a lot of audio response and that kind of thing. It's a highly skilled task for robots, or humans too, for that matter. They can fetch you breakfast and other things. There's exoskeletons, robots that you can wear, like Iron Man in the movies. Not quite as sophisticated as Iron Man, but it's getting there. They can give you a 5x improvement in strength, so you can lift hundreds of pounds with ease. You can curl 100-pound weights for hours on end, as long as the battery lasts, and it lasts for a few hours. So these are exoskeleton kind of wearable robots, and there's ones for underwater that can help you swim real fast, like dolphins. There's ones that are airborne. You can kind of wear a hover suit. These are kind of a clunky ones, much smaller ones that kind of form-fitting and allow you to fly for at least a few minutes until you run out of fuel. Ones that allow you to walk upstairs if you have issues with ligaments or muscles or other issues. There are robots that will operate on you in hospitals. How many know that sometimes robots operate on humans, medical operations in hospitals? Yeah. And 10 years ago, it was amazing and novel and kind of scary, but they're much more precise than humans. They can do micro-incisions into a tiny little hole, go in with this tiny little medical instruments and do micro-sutures inside your body when the incision is just a few millimeters across, and you just put a Band-Aid on it and you're good to go. You don't even have to stay overnight. And with less chance for infection, and they can move with micron precision, something that humans can't possibly do. And so having a human go into you with big stubby fingers and open up your chest, it seems almost barbaric now that robots can do it with much more finesse and accuracy and safety. So one of these things cost like $1.5 million. Many hospitals have it. And of course, there's still doctors lurking around, watching the robots, making sure they're doing the right thing, so nothing terrible happens, obviously. But the robot's doing all the heavy lifting during the operation. It's programmed to do the right thing, and of course, under doctor supervision. And so robotics are even going into the medical field, into operating rooms. I think this one's called the Da Vinci system. It's been around for almost 10 years now. It's not even new. And there's conferences every year on unmanned systems, including aerial and seafaring robots and spacefaring robots. This one is specifically for underwater robots, submersibles. That's specialized. So we talked about science fiction, we talked about reality. I want to show you a few places where reality even exceeded science fiction, not just matched it. And one of them is a Star Trek communicator, beam me up, Scotty, of the old Sirius type communicator. Captain Kirk would call the Enterprise. Of course, that's what it looked like. In the 60s, it was very novel that you can talk from anywhere to anywhere. Now, we all got them in our pockets. And now, they're not just a little communicator just for talking. They're full-fledged communication devices, such as iPhones and smartphones that can also allow you to surf the web and text and email and shop and watch videos and a whole bunch of other things that Captain Kirk could never even hope to do with his primitive little communicator that at the time seemed like, pie in the sky kind of science fiction device. So here's an example where reality far exceeded the science fiction image that preceded it. Of course, some of the early smartphones, the Motorola's, StarTech or Razors, actually took the form factor from Star Trek. They were inspired by the series. So before we had full smartphones, we had sort of Star Trek communicator-looking devices that would flip open, and about 10 years ago, 12 years ago, until the iPhone came around, and now they're all kind of monolithic-looking, slabs without any hinges, which is probably better. So just to put in perspective, an Apple iPhone 6, say, is like almost a 2 gigahertz processor, 128 gigabytes of flash, now up to 256 gigabytes, and so on. Comparing it to a supercomputer from the 1970s, the Cray 1 in particular, it's much, much more capable than the Cray 1 supercomputer, which only ran at 80 megahertz, had only 4 megabytes of RAM, and cost some $8 million, whereas iPhone is under $1,000, even for the high-end one. So that's an improvement of almost 400,000 times in terms of price-performance ratio, computing power per unit cost, which is amazing. That's without inflation even. If you take into account inflation, it's probably several million times more powerful, the iPhone you have in your pocket, than the fastest machine on Earth that occupied the whole room. That's how much reality has exceeded science fiction in the form of smartphones. And of course, in the movie 2001: Space Odyssey, you see a computer beating a human in chess. This is 1968. Again, at the time, it seemed far-fetched, but fast forward about 30 years, and Deep Blue beat Garry Kasparov, world champion in competition rule level chess. And since then, humans have never beaten computers again, and it will never happen again because computers keep improving, and humans stay basically at grandmaster level capability, which is nothing to sneeze at, but computers are a super-duper grandmaster, playing at the level of, if you know chess, it's on the ELO scale of about 3,300 or 3,350. No human has ever exceeded 3,000 on the chess ELO scale of chess rankings. And by the way, this happened 20 years ago. This is nothing new, this computer beating the world chess champion. So again, reality has exceeded science fiction by a huge margin there in chess playing, and not just chess, but other computer games, not just computer games, but there's Garry Kasparov being very despondent about being beaten. Kind of dramatic movies were made about, documentaries. The Brain's Last Stand, exclaims Newsweek that week, that month, and of course, it's just chess. But later, more recently, IBM Watson have beaten the world champions in Jeopardy, which is actually a lot harder than chess because it's AI and natural language. It's not just brute force, branch and bound kind of tree searching. You have to understand utterances, speech, form natural language responses in grammatically correct English, and this is more challenging. It happened a few years ago, 5-6 years ago. And just recently, just last year, a computer AI has beaten the world Go champion, first the European champion, January of last year, and then Lee Sedol for a $1 million purse, and that's quite an incredible achievement. Even experts in AI and algorithms didn't think this will happen for decades and maybe longer, for technical reasons having to do with the size of the board and the size of the game tree. Chess has like 10 to the 65, 10 to the 70 roughly possible game positions. Go has like 10 to the 160 or 170 different game positions. It's a very, very subtle game of strategic global connectivity. The strategies there are even more subtle than those of chess. So just happened about a year ago, that computers have finally beaten humans in Go, and of course, now humans will always be behind because the computer software keeps improving. Humans pretty much stay at grandmaster level. Again, nothing to sneeze at, but that's a fixed point. It's bounded by the human brain and the number of neurons we have and so on, and our lifespan too. You can only get so much experience in a fixed lifespan. Computers, they go forever. Right? Keep improving, no bounds. And of course, self-driving cars. Science fiction, we saw Minority Report, 2002. You know, iRobot, Will Smith had this cool car that drove itself, you know. And of course, we had the Grand ARPA Challenge some 10 years ago, where finally we had prototypes that can drive themselves. Fast forward 10 years to the present, and we got the Tesla Model S that drives itself. It's about to go fully robotic later this year. And as an extra cool factor, it can go 0 to 60 in 2.3 seconds. I made that slide, I said 2.4, because at the time it was 2.4. With a new software update, it improved to 2.3. So it's amazing that a software update now improves the performance, the physical performance of your vehicle. Of course, it's understandable. It's all software driven. It's all drive-by-wire and so on. Other places, reality are catching up with science fiction. We had Rosie the Robot in the Jetsons back in the 60s. It's cartoonish kind of robot that did household chores. Now we got the Roomba, and we got the Luge. It's a gutter cleaning robot, and we got robots that clean pools and robots that can make breakfast and so on. So household chores are going robotic too, and some of them are already products, others are prototypes, but you can see where it's going, the direction. Autonomous vehicles, you know, military platforms. So we have the Terminator movies, right? The T-105s that were kind of primitive. This is from the movie, James Cameron. You've all seen the Terminator series, most of you, I hope. It's kind of cool. Now we got robots that look pretty much like the Terminators from the movies, and except this is real. This is a product, cost is a few $100,000. Battery will last for days. You can put on board all sorts of sensors and weapons and missiles and bazookas or whatever it is you need for a particular mission. It'll roam around. It can autonomously look for targets, following the specs, following its software. It can also be human controlled. If there's a human in the loop, it's only for political and legal and maybe moral purposes. You don't want to necessarily give this platform trigger fire-free permission to shoot to kill without human intervention, but it's not necessary. You can certainly do that, but to avoid embarrassment or political strife, you probably want to let a human make the final fire, no fire decision when it acquires a target, just in case. But these things are now fully autonomous. In the movie Terminator, we even saw motorcycles. There were kind of Terminator-type motorcycles, can go on their own. That's movie. Here's reality. Again, you can have motorcycles that go on their own, including balancing and not falling over, and navigating and doing all the other things too. So again, reality on the right side, science fiction on the left side. Reality is catching up and beginning to even exceed in certain ways the science fiction scenarios. You know, we even had in the movie Terminators, we had hunter-killer kind of flying drones armed with guns and bazookas, and we have that too now in real life. We see drones that are in the form of helicopters, and of course drones that are much more than helicopters. Some can go supersonic, like the X-47 Pegasus. Again, this is not even new. This is over 10 years ago by Northrop. And here's another one, again, supersonic drone, the X-45 by Boeing a few years later. These things can go supersonic, and they're armed. They got Hellfire missiles, armor-piercing missiles. These things can take out tanks from the air and fly faster than you can actually see overhead because they're flying supersonically. And of course, wearable robots. How many have seen Aliens back in the day? Cool movie. Sigourney Weaver there puts on this, what is called a power loader. Basically, it's a forklift, but no wheels. It's just hydraulics, and you kind of walk around, can lift many tons of weight. Kind of clunky looking, but at the time, pretty cool. She was fighting the alien monster with that. Now we got that too, in reality. So you can wear these robotic exoskeleton and lift hundreds of pounds of weight, and you won't even feel it because it's the exoskeleton that's doing the heavy lifting, literally. And it's got its own power pack. It's good for a few hours. You can carry a lot of weight, walk pretty fast. And of course, we all know Iron Man, Tony Stark, right? The movies. I collect comic books, by the way, so I've actually read this comic much longer than you've been alive, most of you, back in the 60s, 70s. I've got the entire run, actually. Iron Man comic, I'm proud of that. Decades before the movies came out. Anyway, now you can buy a suit. You can buy a sort of a exoskeleton suit. It'll multiply by your power by 5x. That's a lot. The battery will run for several hours, maybe 5 hours on a charge. And the cost is $60,000, so it's not cheap. But if you can't afford to buy it, you can rent it for $600 a month. That's actually affordable. So you can all rent your Iron Man suit, for $600 a month. You can do amazing things with it. The company that's producing it is called actually Cyberdyne, which is kind of a nod to this fictional company from the Terminator series, Cyberdyne. So reality, again, catching up to science fiction. We're not quite Tony Stark yet, but this thing can't fly yet. But there's separate suits that can fly short distances based on the limited fuel that they can carry. But we're getting there too. In the movie Logan's Run, there was a medical robot that did operations on Michael York at Farrah Fawcett back in the day. And nowadays, of course, we mentioned already the Da Vinci system, robot surgeon that can operate on you. It costs about $1.5 million. Many hospitals already have that. Just as a little bonus, in the Star Trek series, there's a cloaking device that Captain Kirk keeps trying to steal from the Romulans. And of course, Harry Potter's got an invisibility cloak, again, a cloaking device, one that you can wear and makes you invisible. Well, we got those too now. It's not quite the cloak that Harry Potter wears, it's so versatile and foolproof, but we got a cloak that you can wear and will make you very, very camouflaged. You won't be completely invisible, but you'll look like that, basically. It's like the suit that the alien was wearing in the movie Predator. It kind of blends it with its background environment, if you ever saw that movie. And there's meta-cloaks that can cloak objects at certain spectrum wavelengths. It doesn't work across the spectrum yet, but, so Harry Potter's worked in visible light spectrum. Of course, if you're shown X-rays or infrared at Harry Potter with his cloak on, I'm not sure if you'll be invisible or not. It's an interesting experiment, thought experiment, I guess. But we're even beginning to develop invisibility cloaks now. So reality is catching up with science fiction pretty aggressively. It always has, and there's no reason why it shouldn't continue to do so. In some cases, it far exceeded the science fiction vision, like with Captain Kirk's communicator. And this cartoon again about what humans can do, what technology can do, that is surprising, and we keep predicting that only humans can do so and so, like preview a movie or have common sense or drive cars. So even that is now wrong. Cartoon is only a few years old, but it's outdated. This thing here, only humans can drive cars, belongs on a floor now. So we need another cartoon that's updated because reality is catching so quickly with science fiction. So again, we started with the Turing test. What's intelligence? What's mind? What's consciousness? Sentience? We still don't know. It's hard to define. These are fuzzy subjects, concepts. But machines have already exceeded humans in many things, and that's just going on and accelerating in most cases. It's not subsiding or going back. So there's fewer and fewer things that we can latch onto as things that we can do as humans that machines can't still do or won't soon be able to do. Okay. So where is all this is going in the long arc? Again, it's hard to predict the future. It's hard to know exactly, but here's one vision. It's called the technological singularity. There's a lot of people who are proponents of this, who are very smart and experienced in technology, and it started with Ulam and von Neumann back in '58. Ray Kurzweil is sort of the current guru of the singularity theory, and it has to do with sort of the limit point of this acceleration in technology and where it's going. And the idea is that intelligence, machine intelligence, artificial intelligence will exceed humans and design better machines, because once a machine can think like a human, it can do whatever a human can do, including designing other machines, other better machines or other better versions of itself. And so this will become a feedback loop. Machines will design better machines, which will design in turn yet better machines than that. And it'll happen faster and faster and faster, because when they're better, they're also faster, and the design cycle will speed up, and before you know it, it'll kind of run away from us as a feedback loop. And it'll happen so fast, it'll be some sort of an intelligence explosion. Again, that's the proposed theory, that's sort of the vision. And it may or may not happen, but all indications point in that direction. Some form of this could very easily happen. And then human intelligence will be sort of left behind in some ways because it's not evolving any more quickly than natural evolution. You know, it took us millions of years to get to this form and this level of intelligence. It's not going to change overnight, and that's one of the problems we're having as a species. Our technology is improving by leaps and bounds very, very quickly. We have nuclear weapons now, we have space flight, and we have computers, but our intellect is exactly what it was 2,000 years ago, back in Greek and Roman times. Even more worrisome, our ethics are still what it was 2,000 years ago. So now we have very, very powerful tools that can basically enable us to destroy ourselves and the entire planet and most other species that live on the planet, yet we think in terms that are thousands of years old, where we're still living in caves and wearing togas and fighting with spears. So that's not a great combination, but I'll leave that alone for now. But this intelligence that's artificial, it's exploding, could basically far outpace us. And at some point, we'll just be spectators, kind of watching it and not even quite understanding what it is doing. It being this explosion of intelligence that keeps bootstrapping itself better and better and faster into the future. So, you know, he proposed this law of accelerating returns as opposed to diminishing returns. And if you want to read an interesting book about it that sort of explains all that, that's the one. The singularity is near. And it's, of course, this doesn't come without some warnings. Once you have such a fast-paced acceleration of intelligence and kind of law of accelerating returns, it can also go awry. And we have lots and lots of movies about that too, beginning with Mary Shelley's Frankenstein and more modern tellings of the story of Frankenstein with Arnold Schwarzenegger and Terminator and many others. More recently, Bill Joy and Eric Dexler basically warned us of gray goo, the gray goo phenomena. This is like Keanu Reeves in The Day the Earth Stood Still, the new version. The old version I think was better, but the new version where nanobots kind of go around and use all this stuff around us as raw materials to make more copies of themselves, and before you know it, the whole planet can become a big blob of gray goo. Not a great scenario, certainly not for us. So he doesn't just say that about the singularity. He basically says, here's some data about it. And of course, we know of Moore's law, the number of transistors accelerating, improving, doubling every couple of years. But this exponential increase, such as Moore's law, is not just about transistors on a chip, even though Moore's law is typically about transistors. He says that there's many Moore's laws going on concurrently in parallel across many other fronts, exponential improvements. Processor performance certainly improving exponentially. These are log scales on the y-axis. So we had the Pentium, now we have the Xeons, and later we have even faster processors. And even these graphs are quite a number of years old. The trend has been ongoing. So processor performance is growing exponentially. The transistor price grows exponentially, shrinking exponentially. In the 70s, it cost several bucks to buy a transistor. Now it's several, billionths of a dollar to buy a transistor, because you have billions of them on a single chip. It only costs a few bucks. Microprocessor cost per transistor cycle, again, decreasing exponentially. All these are log scale plots. And dynamic RAM price, memory, improves exponentially. Magnetic data storage, disk capacity improves exponentially. If you remember, back in the day, disks were 20, 30, 50 megabytes large. Eventually, they had a gigabyte disk. That was a big deal. It wasn't that long ago. It was within your lifetime. And now, of course, you have terabytes for only a few dollars, in terms of disk, and it's still ongoing. Exponential improvement in data storage capacity. We have cloud storage capacities of not just terabytes, not just petabytes, but exabytes of storage. Internet data traffic is increasing exponentially. Again, log scale plot. Supercomputing power increasing exponentially. So again, he's pointing out to Moore's laws all over the place. Of course, they're not called Moore's law. They're the analog of Moore's law, but still exponential explosion in various milestones and growth of sequence genomes. Even the number of patents granted every year grows quite much faster than staying constant. There's more and more innovation. You'd think there'd be less, right? Famously, the head of the patent office some century ago or so said everything that can be invented was already invented. Of course, now it seems quite naive to say anything like that. In fact, it's quite the opposite. We have more and more inventions, not less and less, even though many things have been invented already. And various milestones in evolution and technological exploration is sort of shown here. First stone tools about 1 million years ago, emergence of first humanoids maybe 100,000 years ago, discovered fire like 10,000 years ago roughly, invented numbers about a couple thousand years ago. Democracy was invented here by the Greeks 2,000 years ago, and so on. But this is a log scale, and these milestones are getting more and more dramatic, and fewer time passes in between them. And now we have milestones every few years literally, and sometimes every few months, right? Most of you probably remember not having a smartphone. That's not a big, feat of memory. Just smartphones are just a few years old. But I remember not having a web, 20 years ago. The notion of going to some website, getting information instantly was bizarre. You'd have to go to a library, look through some stacks, open a card catalog, find the book if nobody else checked it yet, and then open the book and spend a couple hours, and maybe you'll find what you want, and likely not, because it's probably not the right book. Nowadays, it's only a few seconds on the web. So these milestones, technological milestones, are happening quicker and quicker. Again, this is all data in support of the technological singularity theory. So what is he saying? Basically that the universe has certain distinct epochs, time periods. So the first epoch was billions of years ago, and physics and chemistry kind of settled in. The laws of physics kind of emerged, and biology eventually started taking place through evolution. This was a couple of billion years ago. Single-celled organisms formed, and complex molecules, DNA and so on, that then assembled into cells. And then a few 100 million years ago, it began to have higher levels of complexities into multicellular animals. They evolved brains and other organs and became more sophisticated and started going onto land from the sea and so on. And then, of course, we invented technology. And by the way, these epochs shrink exponentially in terms of their size. So a few billion years for this epoch, a few 100 million years for this, a few tens of millions of years for this, and only a few thousand years for the technology, beginning with stone tools and bronze tools and iron tools and swords and that kind of thing, and wheels and levers and rack and pinion mechanisms. And then later in this technological era, we had electricity and motors, and then transistors, and then computers, and now iPhones, and here we are in this epoch here. And now we're on the cusp of reaching this next one. And this next one is where he says the technological singularity would explode, and this cycle of accelerating returns will take place, and humans will become sort of spectators, looking at their own technology and how it self-evolves from there. And he says that's only a few decades away. So this epoch here is just a few decades. And then he says the universe will wake up, everything will become smart and intelligent, and it'll explode out from the solar system out to the stars and be self-sustaining, build its own spaceships wherever it goes out of raw materials and form colonies. This technological wavefront, which we bootstrapped, but now is kind of running away from us. Now, that's the idea. It's not necessarily exactly what's going to happen, but there's a lot of evidence that points in that direction. I showed you some of the exponential growth and charts and so on that he says are relevant in that, and it's the truth will probably be somewhere in between sort of staying the status quo and this fantastic version of what might happen. But I think it'll be really cool if this does happen. I mean, this doesn't alarm me. I think if humans were just a bootstrapping mechanism for whatever else is on its way, I think to me that would be an honor. Just like, one chimpanzee can turn to the other chimpanzee and say, you see these humans? We did that. you know. Even though, of course, we turn around and kill many of them, and you know, do all sorts of crazy things. You know, it's still kind of an honor to give rise to the next level of complexity and evolution and sophistication and intelligence and so on. So to me, it's not threatening, but to some people it is, for all sorts of reasons, not just, you know, kind of innate selfish reasons, because we want to be in charge and we want to be on top, and we don't like when anything outshines us. You know, we're very kind of egotistical that way as a species, very self-centered as a species, immature. But you know, they bring into also religion issues and the notion of soul and something very, very special about humanity and this and that. You know, the dinosaurs probably thought there's something very, very special about them too. You know, and again, yeah, exactly. We chuckle when we hear that. And one day, whatever succeeds us will chuckle when they hear what we said and how we behaved now in this era. But that's the idea. Any thoughts or questions? Or don't mean to alarm anybody with all these crazy ideas, but you know, I think you should be aware of that. There's entire institutes studying these things. So you know, roughly on this timeline, we are roughly here between this fourth and fifth epoch, and our technology is now getting sophisticated enough to make this jump. And that's what he calls a technological singularity, because it sort of will implode and explode out, you know, reaches some sort of a tipping point, if you will. That's a pretty cool set of ideas. So the gray goo we mentioned already, the idea that this can run away from us, not in a good way, but in a Terminator kind of a way, something that we will actually regret. That can happen too, but it doesn't have to be malevolent. It could be benevolent or just neutral. Just like cars. I mean, you're not afraid of your car. Your car can lurch forward and crush you. And occasionally it happens. It's called accidents. Right? But you don't go around in living fear of your car just because it can do that. It usually doesn't do that. Right? And smart cars will not do that. They will deliberately detect you and avoid running into you. Even if the driver inside tells them to, they will refuse. And that's not science fiction. That's happening right now with many cars, including the Tesla and many others. The car will literally not let you do something atrocious if it can help it. So, you know, there's all sorts of warnings about it too, and our natural inclination to be cautious. And, you know, people have been writing papers about it. There's a good article about this notion of gray goo and the dangers of technology by Bill Joy, who founded Sun Corporation. It later was purchased by Oracle. He also invented Java, so he's no slouch. And he puts a lot of warnings out there that we should be cautious in what we construct technologically and so on, because it's not always easy to predict the consequences. There's rebuttals to that as well. I'm presenting one here. You can read it at your leisure. And there's a Singularity Institute. Every year they get together. It's a whole conference, and people get together, including Ray Kurzweil here, and many other luminaries and people who are also in themselves pretty impressive, to talk about it, you know, study the consequences, brainstorm about ideas, how to get there, how to prevent calamities from happening, gray goo kind of scenarios. And some of these people are, you know, Peter Thiel and, of course, Stephen Wolfram and others. Pretty impressive kind of captains of industry, billionaires founded entire industries. So can't say they're not familiar with the technology. They invented many of the technology that we all use. So they're no slouches. Of course, some of it is highly speculative as well. It's not obvious that this will or will not happen, or what form of it will happen. So for further reading, I'm giving you a bunch of links here. You can follow them, you know, at your leisure. So we started with a Turing test, what's intelligence, can machines think, and explored a lot of these ideas, showed you science fiction versus reality and how reality catches up to science fiction, in some cases exceeded already science fiction. And it's pretty cool, and things are moving very fast. Every month you have new developments in robotics and AI, achievements and products that you can buy, and automation and smart cars. You know, within a few years, every new car that will be sold will be a smart car. It will be a car that will not allow you to run into people. It will be a car that can avoid accidents for you. And in 2 or 3 years, it'll be cars where you can just go to sleep in the back seat and it'll wake you up when you reach your destination. You can fetch it from your iPhone. It'll come summon, you know, you can summon it from your house. It'll come pick you up wherever you are and go back and park itself wherever you tell it to, or find parking on its own. So that's about a year or two away now. Any questions or issues about any of that? It's pretty intriguing visions of the future, and some of them these visions are already here. Our military is already building more autonomous self-flying drones than actual airplanes with pilots in it. That actually flipped a few years ago. Most military vehicles now are robots. I'm not making it up. Yeah. It'll be a combination of things. If you want to add up numbers together, you still want to use, classical algorithms. If you want to find shortest paths, if you want to sort, you might as well use these classical algorithms because they work and they're efficient and they work pretty well and they're provably correct and so on. But for fuzzy things, you need more esoteric algorithms like machine learning and simulated annealing and all sorts of kind of heuristics that is hard to quantify algorithmically using straight line code, using just nested loops and things like that. Remember, animals, organisms, humans, we don't think using straight code and nested loops and so on per se. We have large neural networks in our heads with hundreds of billions of neurons and trillions of connections between neurons, and it seems to work pretty well. And the reason we know it works pretty well is because here we are. Everything you see around you is output of that mode of computation, neural nets, including all these other computers. We invented silicon computers; they didn't invent us. So neural nets have a lot of promise, and machine learnings are based on neural nets. So that's probably not going to go away. The Tesla Model S, the self-driving model, uses neural nets to drive itself around the city and recognize objects through its host of dozen or so cameras, and so it's working pretty good. If it works, keep using it. But it's not the panacea and the solution to everything. You don't want a neural net adding up your checking account balance every month because it's fuzzy. Even if it's a penny off or $1 off, it's not good enough. And neural nets kind of are fuzzy. So they're good for certain things, not good for other things. And there's no reason why you can be both. It's a combination. You can have your neural nets and you can have your sorting and classical algorithms too. And you can work side by side, and each one does what it does best. And together they achieve great things. That's okay. That's probably how it's going to be. That's how it already is. What else? So I made a list of a lot of the stuff that we covered in this class. It's kind of interesting to retrospectively see what we talked about, approximations and axiomatic method and various algorithms for things to colorability. I'm highlighting in red a few things, but there's chess playing programs. We just talked about that today. And the last time, chatterbots, Chinese room version of the Turing test. Chomsky hierarchy was all over the place, right? Church-Turing thesis. And this is alphabetical, by the way. Just alphabetize it just to show you what the breadth of things that we covered. Cardinality arguments, like infinities and countability and uncountability. Cellular automata, like a game of life, invented by Neumann in the abstract, made specific by Conway in the 70s into particular. Cartesian coordinates, captchas, Cantor and his ideas about infinity and transfinite arithmetic. NP-complete problems like cliques and other things, satisfiability, colorings, NP-completeness, proofs by contradiction, plenty of those, right? Concatenation, De Morgan's law came in handy many times. Decision versus optimization, right? Recognizability versus decidability. Diagonalization, very powerful technique to show certain sets are bigger than other sets, even though they're all infinite. Cook's theorem, that ushered in NP-completeness. Again, just a few random things highlighted in red. The rest is alphabetical. We're already up to over 100 things, and we're only up to D, just to show you the breadth of stuff that we talked about, and techniques and proof types and concepts and ideas and cool facts that we mentioned and talked about. Dovetailing came in handy many times, right? Putting things into one-to-one correspondence, for example. Lots of proofs were by counterexample, right? We showed how to encode things as other things, enumerating things. A lot of existence proof, also non-existence proofs. We gave plenty of each. All right, we talked about Fermat's last theorem, and Andrew Weil's solution to Fermat's last theorem was open for 350 years. Finite automata, we discussed a lot about that, formal languages, right? Finite automata, various incarnations, including generalized finite automata, even infinite automata, not just finite automata. Gödel's theorem, his incompleteness theorem, every formal axiomatic system is incomplete. There are things that are true but not provable necessarily. It's a flaw in every axiomatic system. Grammars, we talked about context-free grammars and talked about grammars in general. And we kept showing the picture of the extended Chomsky hierarchy, this Venn diagram with lots of classes inside each other as a set containment kind of relationships. We're up to G, almost 200 things. It's a long list. We talked about the halting problem again and again. We proved it's undecidable. That's one of Turing's many contributions to humanity. Talked about Hilbert's problem, in particular his 10th problem, and in fact we talked about all of his 23 problems. The 10th problem was particularly relevant because it talked about whether polynomials can compute if they're computationally universal. The answer is yes, surprisingly, and it has a lot of other repercussions. Incompleteness, right? Gödel's theorem. Talked about infinite hotels, and that ushers in some ideas about transfinite arithmetic and transfinite objects, infinite objects. Whole hierarchy of infinities, in fact. You take the power set of an infinite set, you get a bigger set, even though they're all infinite. And we talked about clean closures, like graphic orders, attempts to enhance machine models. Some succeed, some fail to enhance. Finite automata, you can enhance it in all sorts of ways. Turing machine, not so much. Almost anything you do to it doesn't enhance it, keeps it pretty much identical in what it can do or not do. And that makes it the most powerful machine models we have so far, simple though it is, a bunch of states and a transition function and a scratch tape. And we talked about reductions, these two ovals, A to B with a function that preserves membership. That, in fact, induces NP-completeness. If you put a time bound on it, it's polynomial. Very important concept. Talking about Occam-Razor over and over again. In fact, it kind of permeates everything we do. Proofs should be simpler. Arguments should make more sense and have less moving parts. Axiomatic systems should have fewer axioms, not more. Be thrifty in design, in thinking, in arguing, in proving, in engineering. Very, very powerful concept, but also in art and architecture and other things. The more assumptions you make, the more moving parts you have in the system, the more suspicious it becomes as being a correct description of what's really going on. It seems more and more kludgy the more bells and whistles hang off of it. Again, Occam's razor in many, many scenarios. And we talked about oracles, one-to-one correspondences, pigeonhole principle. Imagine how many times that came in to save the day in proofs and in arguments, simple though it is. And all of you supposedly have read Polio How to Solve It. It's required reading, one of the best books on problem solving ever written. Short book, but very, very insightful. Simulations and dovetailings and P versus NP. We talked about NP-completeness. Again, the list is long. We're up to P, 300 things so far. We talked about power set and Principia Mathematica by Russell, how we axiomatized all of mathematics and showed how it could be reduced to set theory. Pretty impressive. We didn't know that. And P space, polynomial space, we saw reductions of various types, especially with NP-completeness. Talked about regular expressions and regular languages a whole lot. We showed equivalence between those two as representing the regular languages. Q automata, turns out it's as powerful as a Turing machine. It's one of the problem set questions. Basically, you can flush the queue and do arbitrary computations without losing what's on the queue. A stack, you can't do that as such. Talk about real numbers and rational numbers and difference between the two. Rice's theorem, almost everything that you can name as a property of recognizable languages is undecidable. So it's basically in one fell swoop we showed an infinity of undecidable properties. In fact, almost all of them are undecidable except the trivial one, the one that's always yes or always no. Everything else is undecidable by Rice's theorem. Very, very powerful, sweeping negative theorem Resource-bounded computation, when you restrict the time or space, you get theories like NP-completeness that are very useful because they bundle problems together. Together they stand, together they fall with respect to complexity, intractability, and so on, feasibility. And simulations is a very powerful technique to show that something is equivalent to something else, where A can simulate B and B can simulate A. They're both equivalent, whether it's a machine model, a grammar, type of language, whatever. We talked about minimizing states. Again, I'm just highlighting a few things in red. We covered most of the things that are not in red as well. We talked about uncomputability, decidability, recognizability, Turing machines, Turing degrees, levels of undecidability, some of which are more undecidable than others in the sense that if you can decide A, you still can't decide B, even though A is undecidable by itself. B is more undecidable than A, therefore. So it's an interesting concept. It kind of parallels Cantor's levels of infinity, hierarchy of infinities, hierarchy of undecidability. Pretty esoteric topic, but very insightful, and from that flow a lot of other interesting results. Triangle inequality, again, came in handy in various scenarios. Transfinite arithmetic, again, back to Cantor's work. And the list goes on and on and on. And, the concept, if it was a single concept that I wanted you to walk away with more so than anything else, is Occam's razor. Again, that's extremely powerful. Wheedle down something to its bare essence, polish it to a gem until nothing can be taken away. And then you have something interesting. You have the essence of it in your hands, and you can explore it, understand it much better. Einstein even said, make everything as simple as possible, but not simpler. Again, alluding to Occam's razor. And so in that spirit, there's Einstein simplified. And that's about as much as I want to cover in this course. There's always more if we had more time, but that's a lot. So I just wanted to show you in one fell swoop this long list of what we covered, and that's quite formidable. And again, I think the general concepts are more important than the specifics. You can always go to a book and see a few more examples how a finite automata works, or go to JFlap and construct a couple on your own. But this long arc, the big picture, you won't get anywhere else, and so I figured at least you'll hear it from me at least once in your life or once in your career, if nowhere else. So, my gift to you, that's what I try to accomplish here, get you to wrap your minds around the bigger picture of how everything fits together, rather than harp too much on minutia, even though we did a lot of minutia too, specific things. But that's about it. So any questions or comments? We can start the Ask Me Anything session. We have a good 25 minutes left or so. Yeah. Oh, Morgan Freeman. Yeah, so my buddy Morgan Freeman. So I used to date the woman who is his producing partner. They have a company together called Revelations Entertainment. They make movies such as probably something you've seen, Invictus, with Matt Damon, and they got Clint Eastwood to direct. So anyway, Morgan Freeman is in real life pretty much like he is in the movies. He's this kind of old, wise soul. He smiles a lot. He has this authoritative, kind of soothing voice, just like in the movies. He's very serious, but he makes jokes too. He's very empathic. He talks to people like he's your buddy. He's very pleasant. He has no airs about him. He doesn't run around with a lot of bodyguards in black limousines or anything like that. He's very down to earth. He didn't meet success until later in life, so that partly helps explain why he didn't get to go to his head all this money and success and fame like it does a lot of younger folks like Justin Bieber and whoever. They go crazy with all the attention and success, and they usually end up on drugs, and they sometimes die at a young age too. It's sad. So he managed to avoid all of that. He doesn't even live in Hollywood. He doesn't think much of Hollywood. He has a ranch in Mississippi, where he kind of goes to. He has trouble finding privacy because everybody recognizes him. It's impossible not to recognize him when you see him, or even hear his voice, actually. You just know it's him. So he has trouble finding privacy. So he learned to fly. He has several planes. He flies by himself across the country, just to get away from people. He sails boats on the Caribbean and other places by himself. That's actually dangerous to do, to get on a sailboat and go, hundreds of miles into the ocean, the Caribbean, by himself, just because being alone is actually a luxury for him. Not being recognized, mobbed by people, autograph hunters. He never gives autographs because there's no end to it. If he gives one, then they'll all swoop in. And so it's interesting to see, the price of fame. No privacy, security becomes an issue. All sorts of crazy people start stalking you, and you can't have a moment to yourself anymore unless you're by yourself, and it's hard to be by yourself. There's always people wanting to invade your space. You can't even have a meal at a restaurant. People just keep swooping in, and and it's not that they mean badly. They're very complimentary. It's just annoying because it happens, constantly. Once we had dinner in a restaurant, the few times we actually went out, and it turns out that a lot of waiters have paparazzi on quick dial. And when they see a celebrity, they immediately, text the celebrity, and, they get paid 30, 40, 50 bucks per tip. Just celebrities immediately swoop in with their cameras. And so by the time we finished dinner, it's just an hour, we went outside the restaurant. All of a sudden, there's a whole gauntlet of celebrities, flashes, into our eyes and taking pictures, and we're like, dazed and confused. And just from trying to have a simple dinner somewhere out, so it becomes essentially impossible. So those who think it's good to be rich and famous, well, it's half true. The rich part is good. The famous is sucky. Really bad, terrible thing to be famous like that. It sounds good until you are famous. And then your life is over as you know it. You become a target for almost anything that gets near. Paparazzis and stalkers and media hounds, and everybody's trying to, have some angle, trying to, convince you of something or get you to do something or whatever. It gets very tenacious and tedious. But he's a pretty impressive guy. What else? Is that pretty much, probably more than you wanted to know? Yeah. Biggest accomplishment? It's probably teaching you guys. I'm not being facetious. Now, and the reason I say that, I've been doing this for a long time. When I say you, I mean you and the classes that went before you and so on. So I've taught thousands of people over the years, and occasionally some of them come back, and they thank me for something that I even forgot, that I told them or helped them with, or insight that they had, and they come back 10 years later and say, that problem that you told me 10 years ago about the centrifuge or whatever, the staircase with the cup. I was interviewing for Google, and they asked me exactly the same thing, and I got the job. Now I'm making, $250,000 a year, so thank you. And I'm like, you're welcome. I'll just take 10% of your salary as a, finder's. No, I'm kidding about that. But so it's very satisfying, when they and enough of them come back that, for everyone that comes back, I know there's a bunch more that never make it back or never manage to tell me, but there's enough of them, so I know it's made an impact. So to me, that's very, very satisfying, to empower people like that and to help them succeed and reach their full potential. And that's, just mentoring people. It's good. Now, I know I don't help everybody, and some people will refuse help, and despite my best efforts will, do their best for me not to help them, and that's okay too. It's not like, everybody needs to benefit, but a lot of them do, and it's great. One of my students, one of my former PhD students, is now working for Amazon. He makes about $400,000 a year. And he comes back to me and explains to me how he failed and how he doesn't feel like a success and how all his friends make more money than him. And I'm like, well, what are you talking about? He goes, well, on $400,000 a year, I'll never be able to afford a Gulfstream G7, jet. And I'm like, what? And he says, yeah, I know people that have 2 or 3 of them. And I'm like, okay, but that's not exactly the criteria for success. That's kind of weird, I mean, how many times will you fly a jet, especially if you have 2 or 3 of them, And, so some people are kind of miscalibrated about what success is, and that's a little disturbing. So I have to have all sorts of calibrating chats with people like that, and and ask him, so why do you want a, Gulfstream G7, jet? And he says, well, because I want to impress women. And I say, you want a jet because you want to impress women? Okay, now we have 2 problems. One is, that you think you need a jet, and secondly, that you think that's what it takes to impress women. And if even if some women are impressed by that, I told them, It's probably not the kind of women that you want to impress to begin with. Anyway, so I told them, so what should I do? Well, learn to cook a nice meal, learn to ballroom dance. I mean, women would appreciate that. And so to his credit, now he's taking ballroom lessons. So another win, I think, in mentoring. So that's a mentoring good day. Okay, what else? Yeah. So the biggest change in students' teaching, so I've been teaching for over 30 years, since the 80s. And the biggest change probably is some people abuse the technology that's available. I mean, even in this class, some people have used Google to just cut and paste answers, and it's kind of sad, And, I don't like to play police officer and play gotcha and, deliberately try to find plagiarism at every turn, but when it hits me in the face, it's unavoidable, and I got to do something about it and talk to a person or two or three. But I think that's on the rise. It's people try to find the path of least resistance out of actual learning. And in the 80s, people did more of the heavy lifting because there was no Google, there was no internet. I mean, there was internet, but only email, nothing else. There was no web, there was no websites, there was nothing to look up. You had to go to a library, actually, to find a book and then open the book, if you can even find it, and then study from it. And so people were less lazy and more appreciative and took less for granted, students, and everybody in general, not just students, people in general. And so the biggest change is there's kind of a collective laziness that has set in. And again, I'm not targeting you specifically, it's all of us, all of society is like that. People are now talking in 140 characters or less. Instead of having a face-to-face conversation, they tweet and they text, and that, even people close to each other still text each other. And when you text, it's less personal, there's less nuances, there's less facial expressions, intonation of voice. All information gets lost when you text. And some people, when they text or email, get into big trouble because the other party misconstrues what they said. Because there was no smile and there was no intonation and no wink and no kind of jest, and they thought it was an insult instead of a joke. How many have had that? It happens a lot, and that's kind of sad. So that's another trend that's disturbing. That didn't exist 30 years ago. There was no text. There was no tweeting. There was no Facebooking and that kind of thing. So you asked me, what trends have I seen? Well, these are some of the trends. And I mentioned a few negative things, but I guess to balance that, I should mention some positive things, like, Google is both good and bad. It's great because you can find anything instantly. But if you resort to that instead of thinking and instead of analyzing and instead of asking tough questions, you get fake news and you get strange political elections. And it's not nothing. People assume that if you can Google anything, whatever you find on Google is true. But no, it's not true. Some of it's true, but other things are not true. It's all there. You can Google almost anything and get corroboration to what it is you look. So it's called confirmation bias. Whatever it is you're looking or Googling for, you will find because it's all there. Everything is there. And so people assume just because they look for things and they find them, that's how it is. And that's the problem. That's how fake news propagates. And not just fake news in the political circles, fake news in science and technology and all sorts of scams and phishing and spear phishing. And people fall prey to all these consequences of technology that weren't there 20, 30 years ago. And so it's not better or worse, it's just what's happening. And you can see it too as well as I. It doesn't take somebody particularly insightful to see all these things all around you. And the trick is to avoid, the trick is not to abuse technology. Even Facebook, it's great when you can connect with other people on Facebook across the world, and people you never met or family members spread across large geographical areas, share pictures, videos, birthdays. It's great. But some people abuse that too, and they're on Facebook 8 hours, 10 hours a day. Then it's pathological. Literally, it's almost a mental illness. They're living on Facebook. They're not living in this real life anymore. They're living to impress people, and they get depressed when they think other people are cooler than them and have cooler lives and doing better, more interesting things. Of course, all these other people are pretending too. So a whole bunch of people pretending, and they all get depressed together, thinking everybody's cooler than you. it becomes pathological. My brother is a psychologist. One of his specialties is to treat people with Facebook addictions and video game addictions. Some people spend 16 hours a day in Second Life or World of Warcraft or other virtual worlds. They just escape to it and then they never want to come back. And that's a pathology. They need help. They go to my brother, a psychologist, they say, help me. So he says, just unsubscribe to Second Life. Just shut your account. Don't play those video games anymore. And they tell him, but doctor, you don't understand. In his virtual life, in Second Life, I'm a mayor of this virtual town, and I have a lot of constituents, and they depend on me. I can't just stop. And my brother, has this Twilight Zone moment. He goes, oh, okay, I guess we have to wean you off slowly then. But another disturbing trend. Again, it's, video games are fine. Facebook is fine. Twitter is fine. Until you begin to overdo it. Then it's not fine. Then you need professional help. And there's more and more people in that category, and more psychologists who specialize in these new pathological conditions. Sorry, I know it's blunt, but that's just what's happening. You may know a few of those people. Question? Yeah, so when I see a lot of people copying answers that they don't even understand what they're copying, that's disturbing. So, I then have to start being more of a police officer, more of an enforcer. And I hate to do that. I want to teach you cool stuff, introduce you to interesting ideas, show you a lot of cool TED Talks otherwise you'd not have seen before. And that's all great, but, I could give pop quizzes. I don't want to do that. I could call on people in class, but that would put you on the spot and embarrass some of you. I could give you weekly assignments every single week with a due date, and if you turn it in an hour late, you won't get any credit. Some professors do that. I could do that too. Yeah. Re-engage the engineering? Yeah, well, yeah, so, it's a large class. It's 178 people enrolled, and a lot of you are here most of the time. So it's hard to teach theory and proofs and mathematics to such a large group on a one-to-one basis. We've got Nathan is great, and we've got other TAs, and we have office hours, and I help people that approach me, but it's hard to have one-on-one time. Classes have also grown. Another thing that happened over time. In the 80s, in the 90s, a theory class was 20 people, 25 maybe. That was it. 30, it would be a large class. Now, 170 people is, kind of average. And sometimes we thought this class a couple of years ago or a year ago, it was 215 people. It's hard to get one-on-one time and look somebody in the eye and explain to them for half an hour what's going, because it doesn't scale up to hundreds of people, sadly. So people need to do a lot of it on their own, more of it on their own than not. Even though there's a lot of TAs and weekly sessions and tend to be highly available, you can always come to us. But a lot of people think that it's the job of the professor to teach you. It's actually a little bit off. It's not quite correct. It's your job to learn and teach yourselves mostly. Most of my teaching I've ever done in my life is me hunkering down with a book and poring over it for hours or even days and sometimes weeks and wrapping my mind tightly around something and practicing it, and then I know it. I know it well. And I remember the moment in my life where I realized that learning is my responsibility, not those of my teachers. My mom took me to Caltech. I was a teenager a long time ago. Took me to Caltech and tried to get me admitted to Caltech. He asked to see the dean. I was just a teenager. She was sort of initiating it, like moms often do. And so the dean finally agreed to see us, and he said, okay, my mom says you're smart, so tell me what you've done. I said, well, I've been programming for a long time, and this and that. And back then, it was a big deal. Very few people would have the initiative to program or knew how to program. And he said, okay, do you know calculus? And I said, no, my high school, I was in high school. My high school never never taught calculus. We don't have a calculus class, so that's why I don't know it. He goes, well, what do you mean? You have access to a library, right? I said, yeah, I've been to the library. There's calculus books there, right? You could have learned it on your own, but you didn't. So how good are you really? How much initiative do you really have? You know, your mom says you're the best thing since sliced bread, but you don't know calculus. You could have learned calculus. Some people your age do learn calculus on their own. Whether there's a class in it or not doesn't matter. The knowledge is there. You have to go and get it. And then I realized, heck, he's right. I could have learned calculus. I didn't. It wasn't the fault of my high school. The library is full of calculus books. I could have gone there any time and learned it. And I had this epiphany. Learning and self-improving is my responsibility. If I don't do it, it's nobody else's fault. I can't blame my high school or some teachers that didn't teach it or the curriculum that didn't have it or blah, blah, blah. No. If I wanted it, if my life depended on it, I would do it. Somebody kidnapped my parents says, you learn calculus in 2 weeks, otherwise you'll never see your parents again. I would freaking learn calculus. I will find a way, even as a teenager before the web. Now, why couldn't I have done that without the kidnapping episode? Didn't occur to me. After that incident, it occurred to me all the time. It's all on me. So some of you may not have had this epiphany yet. That's okay. Now you've heard it. Maybe my story will help you have this epiphany for your own life, for your own goals, for your own what you need to do. I'm here to help coach you. I can't do the heavy lifting for you. Teaching is like a coach. I can say, you need more sit-ups, you need more push-ups, you run more miles. But I can't run alongside with you, for you. I can't do the sit-ups for you. And it's obvious when it comes to sports, just like that example. But for teaching, some of you still think it's our responsibility as teachers to inject knowledge into your brains, and you just sit there like little birds who are waiting for the worm to be dropped into your mouth. That's the wrong model. I don't mean to be harsh or critical. I had the same problem when I was your age. I got rid of it when I was in high school, of this notion that somebody else's responsibility or fault. But it's all on me. I'm responsible for my learning, for my success, for my advancement, for my evolution, for everything I do or don't do. It's on me. It's not on the system. The system is there to help. The rest is up to us, each and every one of us. So that was a major epiphany in my own life. Hopefully this will help you too. Yeah. Probably the web. The best thing that happened in my lifetime, I would say, it's hard to beat the web. I mean, it's so empowering, it's so encompassing, it's so cross-cutting. It's pretty darn good. I think the number 2 will be self-driving cars. Not just because it's really cool, but because it'll save 1 million lives a year across the world, every single year. That's more than World War II. Lives saved every single year for cars to be smart. What else? Yeah, any interest in teaching algorithms? In fact, next semester I'll be teaching algorithms. It's a graduate course, but if some of your undergraduates are still here, if you're not graduating, if you want to take algorithms, even as a graduate course, if you're motivated, I'll let you in. I'll be like that dean from Caltech that talked, if you want to be in a graduate course, you're welcome next fall. Just don't mention that to the dean that I gave a blanket invitation to a bunch of undergraduates to take a graduate course. They may look at me funny, but that's my philosophy. If you want to learn, that's great. What else? Yeah. It's not quite the fastest. It's the one with the best performance ratio. It has the best performance ratio in terms of how good the solution is compared to the optimal solution. So speed is not so much an issue. It runs in polynomial time, so it's pretty, it's reasonably fast. But unless recently somebody beat me, that held the record for at least 10 years, I think. So the best performance ratio algorithm. Because the problem is NP-complete. We can't compute the optimal in polynomial time. We don't know how. Otherwise, if we could, P will be equal to NP as a corollary to that. So it's good to have good performance. Yeah. Steiner tree. Yeah. What did I? Yeah, I assumed it was Steiner tree, because minimum spanning trees is a lot easier. There's prim and Kruskal and variations on those. Yeah, but for Steiner trees is similar to spanning tree, except you can add extra nodes as hubs to improve the overall connection, that's all. Spanning tree, you can't use extra points or nodes. Steiner tree, you can. Okay, what else? Yeah. Well, you already know my style, how I teach, so that's kind of the same style. But grad is more, it's kind of like the undergrad version on steroids. A little bit more and a little bit deeper and cover more ground. But algorithms are algorithms. So we still talk about sorting and searching, but maybe more of the fine nuances and other things too, computational geometry. So algorithms actually everything you do is algorithmic. They're everywhere. Almost all the other fields of computer science are about algorithms disguised as other things. Network protocols or security protocols or cryptography. It's all algorithms anyway. It's very, very basic stuff, fundamental. Yeah. If I can teach any class without having be approved, I would teach a class in, I don't know what I'd call it, but maybe I'd call it the big picture, or the long arc, of humanity or something. And I would have a lot of stuff that I taught in the first few weeks. Forget about these Turing machines and Chomsky hierarchy and finite automata, regular languages, and regular expressions. That's fluff, and it's important fluff, but it's details. I would take the first few weeks and expand it into the whole course, and into other technological areas besides, computers, and kind of give you the big picture, how we got here, to this point with iPhones and web and Twitter, and from Stone Age, rocks and swords and wheels to, and where it's going into the future, likely. To me, that's just fascinating. And a lot of the other things are just details along the way. So if you think of a better name, let me know, like the big picture, the long arc, or if you say the history of computing, it's not that interesting sounding. Because the history of computing is like, okay, in 1977, Steve Jobs invented the Apple II. That's kind of mundane. That's just one product for 1 year. But history of computing kind of connotes a bunch of mundane milestones. I'm much more interested in the bigger picture. How we invented the axiomatic system, the scientific method, science to begin with, and where it's going and where it's evolving and so on. So anything else? What else? Yeah. I mean, in general, or ones that I published? In general, I don't know, many thousands, I guess. By now, it's probably tens of thousands. I mean, if you do the same proof different years, does that count? If you have to kind of remember the old proof and redo it, does that count as 2 or 3? I don't know. Thousands at least, maybe tens of thousands. A lot. It's a lot. But like anything else, it's practice, right? I mean, you ask a tennis player, how many, balls have you served in your tennis career? Again, it would be tens of thousands. How many miles have you run if you're a marathoner, professional? Again, tens of thousands of miles over a lifespan. The answer is pretty similar. Whatever it is you're trying to master, you're going to repeat and practice a lot. It's like that old joke about a tourist comes from New York, he stops a cab driver, he says, how do I get to Carnegie Hall? The cabbie says, practice, practice, practice. Anyway, what else? All right, if there's nothing else, then fun.
Particularly interested in game of life and science and whatever. If you guys it's like I don't know. At least that's what I was thinking specifically. Otherwise, I'm open to
I don't know if we have a way to pay for it, but you can do it by remote. Whatever. If nothing comes up, that's okay too. This size solution is maybe contribute.
Yeah.
You wanted a name for the class or seminar. Why not something like the Long Haul or something like that?
Let's do it, the long haul.
Could you teach it maybe like as a flash seminar? They do stuff here at UVA. I don't know exactly what they do.
I'm tempted. Actually, that's what tenure is for. What are you going to do? Fire me? But I certainly am tempted